Maybe we can start. People may join a bit late also, right? Because of other sessions.
Yep. A warm welcome to everyone. Very good afternoon. So, welcome to the fifth annual conference of Women Who Code Connect India 2021, sponsored by VMware. Our theme for this year is building resilience into careers. So, thank you all for joining our panel today. Future of 5G. Let me take a moment to introduce our speakers and moderator for this panel. So here we have Nida Sahar. She's an entrepreneur, writer, engineer, startup fanatic, and she's very passionate about empowering women. Nida has been involved in building women-centric technologies as well as startups and edged communities. Currently, she's focused on building the future for real-time computing with Nife. Thank you, ma'am, for accepting. Welcome to the panel. So next we have Swati Kamat. She's a strategic leader with almost 30 plus years of experience in telecom industry. She worked in India and across the globe over many executive roles. She got selected through UPSC as Indian Telecom Service Operator and worked in various capacities for almost 17 years in public sector. She is currently associated with Ericsson in business area managed services. She worked in Tech Mahindra, Airtel as CTO for Chennai, Tamil Nadu, Kerala, and Karnataka, and later she also worked as a regional CTO for North and West India. She has developed a mindset of business and focuses on leadership development. Thank you, ma'am, for accepting our invite and welcome to the panel. We have Daniel. He's seasoned R&D leader with almost 3 decades of development and management experience in telecom networking. He has led various engineering roles at Indian telecom PSUs and multinational telecom cloud companies as well. For the past 7 plus years, he has been leading global engineering teams for the development of OSS and service assurance suites of products. He also won the Smart Grid Product of the Year 2012 award in the very first year of its inception. He has been a visiting faculty for PG courses in advanced networking and an invited panel member of Academic Curriculum Review Board for many local universities. Welcome to the panel, Daniel. Sridhar, we have Sridhar today in our panel. So he is working as a director RAN at Mavenir. He has been working as a product manager in VMware in Techno Edge and Cloud Business Unit. He's actively involved in keeping abreast of cutting edge deep learning research, evangelizing machine learning and deep learning in both industry and academic circles. He's involved in monitoring people, enabling them to plan and pursue their career aspirations. Thank you, Sridhar, for accepting. Welcome to the panel. We have our moderator today, Neelam Batra. She's a passionate technologist and holds a bachelor degree in electronics engineering from NIT Allahabad. She's currently associated with VMware as staff 2 engineer, service provider, and HBU. She has expertise in telecom domain and machine learning. She also developed a history of working on telecom and networking products. She is right now a Women Who Code leader for Bangalore chapter and a data and a diversity and inclusion evangelist. Welcome you all. Have a nice time. So the stage is yours.
Thanks, Sandhya. Thanks for that wonderful introduction. So, good afternoon, everyone, and warm welcome to all the speakers. So, I'm sure you all must be as excited as me for this panel discussion on future of 5G. So, without further ado, let me start with the first question. So, maybe Swati, I'll start with you. So, you can take this first question. So, 5G is in news for various reasons. The biggest one being the promise of 5G, the higher bandwidth, low latency, and what's the landscape? So, what's the landscape of 5G in India, in Asia, and in other markets? So, you can put your views on the 5G standards, how 5G standards are also evolving.
Thanks, Neelam, for asking this question, and thanks the organizers for inviting me for this panel. Let me divide this into 3 parts. The first is what 5G means for us, what is promised there, what is the landscape in the world, what's the status in India, and how the standards are evolving. So, what is promised in 5G, as you rightly said, Neelam, is the technology is promising a very high reliable speed, and it's also promising a low latency. Latency, as everyone understands, is the time taken for communication between the two, data points. The basic 5G requirements, if we just look at the theoretical part, is that it envisaged a very high reliable bandwidth, means approximately more than 1 Gbps to around 20 Gbps of peak throughput for the consumers. A latency of as low as 1 millisecond, so 1 to 5 milliseconds. Mobility, that means when people are moving around, at what speed till the connection will be through and proper, 500 kilometers per hour. Density, because as you know that as IoT devices are getting added, how many more devices we can add into a particular kilometer square, and which is 1 million devices can be connected. Similarly, 99.999% availability reliability, and for specifically the IoT devices, the more than 10 years of battery life. This was what was envisaged as a theoretical requirement of 5G. It's also governed mostly by the consumer and the industry both needs. If you see 4G, we have been only talking about the consumer needs, our data speeds, etc. Here, the industry is also waiting eagerly for the 5G. And the use cases which are there for 5G, which we'll talk more about as we go forward, is in terms of the broadband, in terms of the fixed wireless, in terms of the massive IoT, which is number of devices connected across, and the you know critical communication or critical IoT. Use cases like smart city, smart agriculture, robotic surgery, self-driving vehicles are also, important part. And 5G is mostly driven by, as you must have read everywhere, it is all about the use cases, and depending on the use cases, how that network evolves. If you look at the landscape, let's talk about the world landscape. So right now, as we speak, we have the 5G networks across 176 operators across the world. So it's already commercially launched. There are 380 million subscriptions already there, as per, in fact, this week's report published by Ericsson. And the forecast is to go to 580 million by the end of 2021. So almost 1 million devices are getting added every day, if you talk about. But the pace of deployment is varied across the geography, so it's not uniform. So like Europe has is a to a slower start. China, US, Korea, Japan, Gulf, they have picked up the 5G deployments in a big space. Asia is just picking up the pace now. So we have these commercial deployments across. In India, we are just, the networks are getting ready, the testings are happening. In fact, all the operators have tested their test trials in terms of taking a test frequency and doing it. Some of the operators are also testing their existing frequencies to be ready for the 5G, and they are also doing the trials on that. And I'm sure that come 2022, when more spectrum will also be allocated, we will have an exciting time in India as far as the 5G is concerned. If you talk about 5G, 5G is coming in three bands. One is a lower band, which is less than 1 gigahertz frequency, mid band, which is 1 to 6 gigahertz, and the high band, which is 24 to 40 gigahertz. So in India, when we are talking about, all the trials and experiments are happening in the low bands, some low bands and the mid bands, with the existing allocated technologies, and also the 3.5 gigahertz, which is a mid band. If we talk about the evolving standards, we are talking about the different standards which have to undergo a change on the radio, on the core, on the transport. All the layers have to undergo a change as far as the 5G is concerned. So, from a multi standard technology radio to a 5G new radio, which is actually powered by beamforming massive MIMOs. The RAN is getting virtualized. We also have a feature called network slicing, and we'll talk about more when we go to some of the other aspects of the 5G. And then, as I mentioned in the beginning, the ultra reliable low latency communication, right? That is an important part of the standard, which has also been developed for 5G. The next one is the distributed cloud. So depending on the usage, the requirement of low latency, the edge computing, and the distributed computing is getting added. Apart from that, this is all on the network layer and also on the core, from a PNF to the virtualized network function to the CNF. The technology is undergoing a change. On the transport, both on the front haul and the back haul, the technology is getting changed from an eCPRI to a SD-WAN kind of a communication on the transport layer. And so if you look at all the technologies, everything is getting a change. But apart from that, the most important part of the 5G, because of its complex nature, is the digital service life cycle management. And this is where a critical part of the management functions, which are also getting enhanced, as well as the charging system. So traditional charging on your data speeds or data rates, or the consumption of your data, is not only going to be charged. So there are different charging systems getting, and the open APIs for everything. So I mean, this is the way the technology and the standards are evolving, Neelam.
Yeah, thanks, Swati. Too much of information. Yeah, I think yeah, a lot of things you have covered. So I'll go to Daniel now. So Daniel, if we come to you, so now let's talk about from technology perspective also. So what are the core ingredients that make 5G as 5G, and how is it different from 4G? A few things Swati also covered. So maybe you can cover more. And will 5G replace 4G? So that question is there in everyone's mind now.
Okay, good. So 5G, as the name indicates, it's a fifth generation technology of telecom networks, right? So that has started trials in late 2019, 2020, early 2020, and continue to expand worldwide. Just to give a quick glimpse of different generation of mobile networks, right? So before I get into the 5G differences, first generation were in use in 1980 and onwards. So primarily first generation was focused to deliver analog voice. And the second generation got introduced in early 1990s, almost 10 years later, with digital voice, CDMA technology. And the third generation came in early 2000s, the 3G. So that brought mobile data. And fourth generation, somewhere in 2010, and that was 4G LTE opened up era of mobile broadband. If you see that it is every 10 years, we are seeing one generation. Starting 1980, 1990 second generation, third generation 2000, fourth generation 2000, approximately. So all these things are leading to 5G, which is designed to provide more connectivity than ever before. So 5G is a unified and more capable air interface. It has been designed with an extended capacity to enable next generation user experiences, empower new deployment models, and which probably will cover. I think that will be covered in later session because I didn't want to get into deployment models now, and deliver new services. So like 4G LTE, 5G is also based on, now coming to the differences, right? So 5G is also based on OFDM, orthogonal frequency division multiplexing, which is a method of modulating a digital signal across several different channels. This is just to reduce interference and will operate on the same mobile networking principles. However, 5G uses new radio interface called 5G NR, air interface, alongside of OFDM principles that is used in 4G LTE to deliver a much higher degree of flexibility and scalability. 5G also uses wider bandwidth technology such as already Swati has covered, sub 6 gigahertz and millimeter wave frequencies, right? So certain specifications that 5G differentiates from 4G, right? So of course, there has to be a backward compatibility in terms of coexistence of 4G LTE and Wi-Fi network standards. In addition, 5G technology is expected to unleash a massive 5G IoT ecosystem, so where networks can serve communication needs of billions of connected devices with the right trade-off between speed, latency, and cost. So some technical rigor, let me highlight at high level, right? So three pillars, I would put this broadly under three pillars of 5G. One is ultra low latency, ubiquitous connectivity, and massive data capacity. I think it is touched upon. Latency is 1 millisecond versus what we used to have almost like 200 millisecond in case of LTE, 4G LTE. In terms of data speeds, it is 10 gigahertz. We are talking in gigahertz versus what we used to talk in 100 Mbps maybe even with LTE advanced, it can go up to 1 gig, where here we are talking about 10 gig. And in terms of bandwidth, yes, it is because of the millimeter wave spectrum with a new radio interface with certain other cell site improving, the cell splitting, small cells, all those kind of things. We achieve higher bandwidth, which is 1,000 times bandwidth per unit area compared to 4G. And also the connection density in terms of within a unit area, how many devices can be connected? That is almost like 100-fold. So these are some of the differences that we are looking at in terms of achieving through 5G technology. So over to you, Neelam, back.
Yeah, thanks, Daniel. So very soon we will be seeing the 6G also. So already talks are there. Yeah. So Shri, the follow-up question for you. So the previous one only. So how can an operator leverage existing 4G deployment to roll out 5G quickly?
A very pertinent question, Neelam. Thank you for that. And thanks to Women Who Code for having me for this panel discussion. So, yeah, I think one of the biggest challenges which people have in terms of rolling out 5G is operators spending a lot of CapEx and OpEx money to both deploy and roll out the network. And here, we should also note that across different countries, the operators need to spend a huge amount of money just to get the license for themselves. On top of that, if the operators need to deploy a complete new 5G network, that is going to be exorbitant, and it may not even serve the business case. So, except for, let us say, new entrants. So 5G is a very interesting thing. There are players who come directly into 5G like greenfield rollout. They stand a huge advantage because their radio planning as well as the technology can completely start off on a cloud native infrastructure and completely software based CI/CD pipeline, cloud based, and everything. You can go all the way through. Whereas an existing player coming from the 4G space, they would have to probably migrate their technology. They're probably not even fully cloudified. They're having many PNF functions. Their cloud strategy is not fully evolved, and the CI/CD pipeline are all not aligned completely to a fully cloud model. Okay. So in this scenario, what 5G standards has done is to introduce this concept called as NSA, or non-standalone architecture. So when an operator is having an existing 4G core, they can just deploy the 5G radios out and leverage the 4G core itself to make the calls go through and get the data connectivity. So it is like a good mix of both technologies. You get the advantage of higher bandwidth on the air interface, but you are trying to leverage your existing infrastructure. And gradually, as the rollout deepens and the operators understand where the markets are, they can expand the core. They can migrate the core. There are existing frameworks for migrating from 4G core to 5G core. It can do it in a smooth transition, and hence I think that is there is a, we can say, a smooth way of going from 4G to 5G. But how smooth that is also an interesting question, especially because the cell coverage, the cell technology, coexistence of 4G and 5G, all these are also challenges which operators need to deal with. So no easy way, but the standards do allow for a gradual migration, if you will, rather than operators spending entire capex and opex to give up on 4G and move to 5G.
Yes, Sridhar, very rightly said. So same challenge. If you see, we have for SaaS applications also. Few companies are directly landing into SaaS, and few on-prem are moving towards SaaS. So same challenge. Yeah, thanks a lot, Sridhar. So Nida, I'll come to you because you are again a startup, and Sridhar said that for greenfield customers it's still easy. So there are many startups coming up in 5G field. So how can startups come together with enterprises to realize the full potential of 5G? Can you put some views on that? Yeah.
Yeah, thank you so much for having me here. And I think I'll go back to what the previous panelists spoke about. One is a software-defined networks, right? A lot of startups today are emerging with paradigm of a software-defined network. How do we, what Sridhar just mentioned is enhanced 4G, the changing the core, right? So there are a lot of startups today that are working on enhanced 4G use cases. There is Mano, there is NFE, there's network splitting, there is 5G mesh, then there is IoT edge computing, there is IoT itself, and then there are a whole bunch of use cases. So each of these startups that are working are all solutions in silos. And fact of the matter is that these solutions on them with themselves alone, they cannot work out. Like if I just deploy a Mano without having a 5G infrastructure, it's not going to do anything. Rather, if I do a 5G mesh technology and not have use cases associated with it, there's no point rolling out. So firstly, the startups today are focused on, one is optimizing the existing network. Second is providing extra source of revenue to the telcos themselves. So it is very important. One thing is the collaboration aspects between these startups, which is the most important thing. The second aspect is access to a lot of infrastructure when it comes to deployment and usage, like the 5G test beds that are emerging in India today from the IITs, IIT Delhi, IIT Madras, as well as Bombay. So access to these test beds becomes very important so that all of them can work in a collaborative mode. So having said that, the emergence of these startups is quite, what do I say, fragmented, and it's completely all over the place. There are startups coming in from Israel, there are startups from Europe, a few from India. So it becomes very difficult for them to even come to a common platform. So projects like Telecom Infra Project, TIP, they have a very good provision in which you can look at different things like network as a service, radio access network, and so on and so forth. And telcos are also a part of the project, as well as enterprises. So they get a chance to work with each other with projects like TIP, so that they can collaborate and do this better. I don't really think that it's a one person's game. I don't think just telcos alone can do this, or startups alone can do this, or enterprises alone can do this. 5G is so huge and so humongous. Like Swati mentioned, there's so many components of it, and the way the landscape is changing, it'll be very difficult if one person says, I'll do it all. Right from moving from cloud native to edge native applications, emerging of use cases, it's quite chaotic. And the only way it can work forward is in collaboration. And that's all I have to say. Enterprises are a little back when it comes to this, because they themselves are trying to get access to the telco infrastructure. That's my understanding, especially in India. But there are associated projects and things like that through which you can get access to telco infra.
Yeah, Nida. So it's a collaboration which is required for and it will be a win-win situation for all, right? So everyone will be benefited. Yeah. Thanks, Nida.
Yeah.
So I'll come to Daniel now. So what are the use cases you see that are enabled specifically by 5G? We spoke about 4G, 5G. So those differences we have seen. So we are coming to the use cases now. And which industries will benefit most from 5G network, and who are few early adopters of 5G?
Okay, I think there are 2-3 questions here.
Yes.
So let me kind of try to combine and okay, each generation wireless network comes with a set of new use cases. So broadly speaking, 5G is used across 3 main types of connected services. One is enhanced mobile broadband, basically the mobile broadband that we have been currently leveraging 4G LTE, but this is an enhanced one. And second thing is mission critical communications. So I'll touch upon that. What is that? And third thing is massive IoT ecosystem. So you can just put it under 3 broad pillars or broad the main types of services. So another thing is, another defining capability of 5G is that it is also designed for forward compatibility. Typically we talk about backward compatibility. Here we talk about forward compatibility, which is the ability of this system to flexibly support future services that are unknown today. So 5G is also keeping that in mind. Now coming to the first, enhanced mobile broadband. So addition to making our smartphone better, 5G mobile technology can open up new immersive experience such as virtual reality with faster and more uniform data rates, a lower latency, and lower cost per bit. In terms of mission critical communication, 5G can enable new services that can transform industry with ultra reliable, available, again, low latency links like remote control of critical infrastructure, vehicle, medical procedures. I think Swati touched upon, so I'm just kind of trying to cover. So it is like connected vehicles, medical procedures, all those kind of things. And third thing is on the massive IoT, 5G is meant to seamlessly connect a massive number of embedded sensors virtually in everything, every device, through the ability to scale down in data rates, power, mobility, providing extremely kind of lean and low cost connectivity solutions, right? So these are some of the or most of the benefits of 5G when it comes to a difference between 4G and 5G.
Yeah, thanks, Daniel, for that. So, Swati, I'll come to you now, and let's talk about the telco companies now. So, what are the main challenges faced by telco companies while deploying the 5G technology? So, in general, you can cover that. Few things are covered by Sridhar also. So, maybe
Yeah.
you can put your
So I
thoughts.
think as Sridhar earlier said that the biggest challenge is that you can't just wipe off the old technologies and just put the new network into the place. So that's the biggest challenge. And this technology, even though it is transformational, it's also helping the operators to have the mix of the technologies when it goes, and the non-standalone mode is very important. The main challenges which telcos are facing is first and foremost the spectrum availability and availability, and that spectrum is always under the government control of each countries, and then that has to be released for the 5G, and that has to be made available. So today the bands which are available for 4G, they can be used for 5G, but to really have a 5G power, as you say, you need to have additional spectrum everywhere, and that spectrum is that availability is the biggest challenge which operators are facing, especially if you talk about India. We're still not
Yes.
got the auction for 5G, but in other countries as well, the bands are not free. Some of the countries bands are not free. They are being made free to for the 5G. The second one is that the complexity of the radio network in terms of handling both the 4G and the 5G, and the deployment challenges for that. That means that every cell site you have to visit again to put the 5G radio, right? Now that is, as you can imagine, in India approximately are more than 200K sites are there. So imagine a 5G for all pervasive network. If you have to roll out, how much of the deployment you have to do in terms of actually getting that ready in physical terms, if you want to put an additional frequency. The third one is that, as again, it's a complex network architecture on the core and the transport and the RAN, the testing, the testing equipment and the testing scenarios which have to be tested to make sure that, and as Daniel said, so many use cases are there. So there could be a testing mechanism which was just testing the network performance, but then here you have to also fine tune the network performance for the different use cases. So the testing becomes a very 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 big challenge for people. And then the devices. So in the 5G, while for example today you just roll out a 5G network and the devices are not there in the market, both you talk about IoT devices and the consumer devices, and the devices have been facing a challenge of the multi-band support. So low band, mid band, high band, all the bands have to be supported by the devices, and that devices ecosystem is not fully ready. I will not say that it's not ready. The devices are there in the market. Now the devices prices. In fact, I was just attending to a seminar, a congress conclave just before this panel discussion, and there we are talking about in India the availability of a handset at 8,000 rupees to a 12,000 rupees handset of a 5G. The devices are there, but I'm saying about the compatibility of it for various bands is another challenge, and also for the IoT. If you're putting as many IoT applications, you need to have a enhanced battery life. So having devices with enhanced battery life and the device chipsets, etc., that's another challenge which is there. And on top of it, all of this is obviously money, the investment. So every telco, even though and this is a capital intensive market, so you have to have money to really, big pockets to really roll out 5G. And last but not the least, the security part of it, because as you're going on the all IP layer, everything, the security is a big challenge which the operators have to face, and they have to make sure. And the management systems, the orchestration systems, the um, unless they are powered by automation and AI and and those things, it's very difficult for humans. Till now, you see our operations of the networks were being managed by human, but now it is not possible for 5G. 5G, you have to have advanced systems, automated systems, which will have the monitoring. So these are in general. I've not touched upon the cloudification or virtualization. Maybe other speakers can cover, but these are general telco problems which every telco is going through the challenge, and they are facing it and then mitigating it. Thanks.
Yeah, very rightly said, Swati. And it again reinforces the same thing that everyone has to collaborate to get the real value out of the 5G.
Correct.
Yeah, so I'll come to you, Daniel. Means what are the, if you want to add to this challenges, that what are few challenges faced in deploying cloud native 5G infrastructure?
Yes, sorry, I was on mute actually. So I think there is one more angle to that of this cloud native, right? So first, let me spell out what is cloud native infrastructure in the context of 5G. So cloud native is an approach to building running applications that fully exploits benefits of cloud computing model. So everyone is quite familiar with IT cloud. IT cloud, what it does, it provides cloud-based services to render enterprise requirements. Primarily data center in the cloud or cloud data center we call. So now on the other hand, telco cloud commonly refers as a private cloud environment to host virtual network functions of the telco network by utilizing NFV techniques, network function virtualization techniques. Further, telco cloud also has got some stringent requirements on the secure traffic flow and latency requirements. So for the communication service provider, what are applications are network functions. Examples of these are some session management functions, or you can consider user plane function. These services and applications are being disaggregated into sort of microservices that run on containers, and the whole infrastructure is changing like cloud-like, becoming more cloud-like, where the complexity completely it is abstracted from the hardware infrastructure that is underneath. So now this is where the challenges from a cloud native perspective, as the CSPs need to be aware of these challenges when they adapt containers and containerized network functions. So couple of challenges, which I think it's already slightly touched upon. I'm just trying to elaborate from that. With a wider scope of application coverage, the 5G operators aim to provide their customers latest, greatest services via fastest means available. So now this is where the deployment and integration strategy needs alignment with cloud-based strategy, because traditionally all these mobile operators, telco operators come from a more classic kind of way of deployment. So here the deployment integration strategy needs alignment with cloud-based strategy. So what that means, it focuses on cloud-based deployment practices, integrating with off-the-shelf solutions that are certified for standard compliance, and then certain things pre-integrated with standard core components from multiple vendors. So mobile network operators here, their challenge and expertise knowledge in building, operating cloud-based networks for disparate services will be very crucial to the success of 5G. The operator needs to ensure that they have the right ingredients to efficiently monetize 5G services and assess new business cases with higher predictability and clarity for optimal 5G service. So that is on the deployment integration side, because of disparate services being supported. Now, the another angle to that is, next one is on the operations maintenance strategy. So that primarily focuses on how you do seamless, agile software upgrades with near zero downtime, right, to user services. This is more aligned with the cloud kind of way of doing software upgrade, unlike the classic way where we take a maintenance shutdown at midnight and do that changes and other things. So these are some of the kind of challenges, I would say, from a network operator perspective when this 5G comes into life.
Yeah, thanks, Daniel. So it's the same challenges which we generally have with SaaS applications also.
Exactly. Yes,
yeah.
yes.
Right. Yeah, thanks for that. So Sridhar, coming to you now. So there are multiple cloud deployments available, private, public, or hybrid. So can 5G be deployed in public clouds? If yes, means then how? And if no, then what are the challenges there?
Yeah, again, a very, very interesting question. Yeah, I think when we all learn about cloud, we get the impression whichever cloud it is, it doesn't matter. And there are many products and technologies and companies making claims. Don't worry where the cloud is. You just make your application cloud ready, and it doesn't matter where you deploy. But I think the 5G has really brought to the front the I would say the differences between or the nuances of these claims made in a very generic context. And let me bring in another aspect here, because that did not get explicitly mentioned by the panelists, but this is quite important for people attending this. There are various flavors of 5G, right? So you have this VRAN flavor, the ORAN flavor, and the traditional flavor, and all of this in the whole picture. I think it didn't come out explicitly. We just want to bring these concepts in as well. So if you look at the traditional way of how 2G, 3G systems were built, it was the manufacturers, the vendors who used to build proprietary hardware, putting in radio concepts and basebands and all those things. And then there was some kind of a generalization which happened when the server part of it got a little more generalized. You had these ATCA off-the-shelf servers, which supposed to be that where people could deploy the workloads. The server is still generic, not vendor proprietary kind of a thing. That happened. And now what we are seeing is the VRAN and the ORAN standards coming in, which is completely, I would say, completely again is a relative word, but it has opened up the entire ecosystem. Let me put that way. So the moment we say we are looking at a cloud native kind of a framework, then the question becomes, can we take a CU or a DU application and go and put it on any cloud, right? The blunt answer is, unfortunately, without testing, no. Yeah, Swati is already in mute. She's telling no. and the ecosystem, the 5G is an ecosystem. It is not a company. It is not a standard. So right from the chipset vendors who are building in 5G capabilities, the L1 capabilities, the accelerators on the chipsets, from there on, you go to the vendors who are manufacturing the servers. They need to integrate these chipsets into their roadmap, and then by the time you come to that point, then you come to the cloudification layer. Then these cloud providers, if you will, they have to make sure that the chipset and the server is compatible to the cloud. And then by the time you come to the application layer, then you have these combinations of the chipset plus the server plus the cloudification layer, and then the application. And so this is just this layer, right? Then you have the handsets, and then you have the core, and so it's a complete ecosystem we are talking here. Now, specific to the cloud itself, when we are talking about public cloud, private cloud, and all of that, the kind of latency requirements we have, specifically for the DU, right? It is still, I would say, pretty daunting to put a DU on a public cloud. One is, of course, the latency requirements. The second is, of course, the DU requires very, very specific L1 capabilities, which I would say the public clouds are trying to figure out how to make that available in different geographies, in scale, and on demand kind of system. So that system, that maturity is evolving. But I would say the low-hanging fruit is to put the CU on the I would say public cloud. That is the second part. Is the word cloud itself is also the word cloud itself, and the way the cloud is deployed is getting changed. So a very traditional and a nuanced and specific way of looking. I had 3 years back. The public cloud is nothing but Amazon sitting somewhere, and you just go on demand, go deploy it. a Google or an Azure, you can do that. Now, if you talk to Amazon and say what is their strategy of 5G, they would say that they are going to put a rack of servers and things in the operator's place and create a cloud. I think you can Google, say, for example, Amazon Outpost and things like that. You will figure out. So the public cloud is not as public as we used to think it was. And the hybrid cloud, even the private clouds are hybrid clouds, the public clouds are hybrid clouds. So the boundaries of those are all getting fuzzy. And I think the entire ecosystem needs to gear up for the 5G rollouts in scale. That is how I would put the whole thing.
Yeah, okay, so you mean to say the cloud meaning itself is changing now? So we have to.
Yeah, the boundaries are
yeah.
no more rigid, and hence, the public clouds are coming closer to becoming coming to the operator, or coming close to. Even if you were to take the case of, say, enterprise rollout, like the NPN networks which you're talking about. So the clouds, the public clouds need to come closer to the operator and to the customer. The private clouds need to evolve to become a more hybrid. So there is all these boundaries getting shaken, and even the models are getting shaken up.
Right. Thanks, Sridhar. So it brings me to next topic now, the edge cloud computing. So Nida, if you can talk about that. So how will edge cloud computing help 5G?
Yeah, this is actually a good segue to what is edge and what is edge computing, and it's actually a very good segue. Like how cloud is getting demystified, edge is an ambiguous term. Everyone looks at edge in a different way, talks about edge in a different way. What is an edge? There is a device edge where you can do on-device computing. Then there is a network edge, that is something that is located away from where you are. Then there's telco edge, which is then something that is coming with 5G, where you have edge deployment from 5G. Then you have cloud edge, which is actually a deployment from a cloud server. Now, edge itself is so ambiguous, and it's varied in the way what people talk about. When we talk about edge computing, the primary definition is computing close to where the end user is. So it can be done on device, it can be done on network, it can be done on telco. It can also be done on cloud, considering cloud is close to where the end user is. But preferably, it's the network and the telco edge that we talk about. So why is edge computing important? Because of the number of devices that are growing. Every household today has at least 4 or 5 devices. I myself own 3 devices. And the way devices are growing, it is predicted there will be 50 billion devices by 2030. And then that means in order to cater the computation that is coming in from so many devices, everything cannot go to your public cloud, cannot go to your hybrid cloud, right? So that's where the telco cloud becomes important. Now, why telco cloud is important is because telco already has the infrastructure. Second, it's close to where the end user is. So it's obvious you add 2 and 2. Devices are in one location, telco cloud is in that location, do computation right over there, and you're sorted. So that's the nuance about edge computing. But yeah, of course, like every single thing in 5G is a challenge. Every single thing in technology is a challenge. There are so many more challenges when it comes to edge computing. Firstly, how does a device get to know where the closest endpoint for computation is? So there are 3 network towers close to you. Where should it go and do the computation? What if it's an AI-based application and the server compute does not have GPUs and TPUs? How does that be taken care of, right? Then the third question is, what if you don't have 5G over there? So what happens? It's a market where you're still in an enhanced 4G environment, or forget about enhanced 4G, you're still in a 4G environment. So what happens then? How do these rollouts impact that kind of a thing? So interestingly, what has happened, at least in APAC, and this is non-telco perspective, so it's slightly different from what is happening, is that so there is a public data centers, which is your cloud, which I call as hyperscalers. That's AWS, Azure, GCP, and so on and so forth. Then there are managed data centers like the NTT Global, NextGen, Control, and so on and so forth from an Indian context. So they have now started rolling out something called as Neo Edge Data Center. That comes in the category of network edge, not so much of a telco edge, because telco edge will come from a telco base station edge device, right? So these people have started rolling it out in APAC per se, even before the 5G rollout is happening. So this is giving some kind of breather for edge computing and for devices to compute closer to where the end user is, but it's not solving the full problem, because there are it is anticipated that there'll be 117 million edge devices that will be rolled out from telcos alone. So what is happening right now is probably 10% of those devices are being rolled out today. So those are the challenges when it comes to edge computing. But like I said, IoT devices, when it comes to smart city use cases, they need an edge computing layer because they need to compute and store data close to where they are. So the grid related information, water services related information, even the parking related information, computer vision related stuff has to be computed somewhere. If it's not happening locally on device, it has to be stored somewhere. So data need not go back to cloud. So that's the idea. And similarly, when you look at your mobile phone devices where you have high compute needs, so again, that need not go back to cloud. Computation can happen close to where the end user is. Only the required data will then go back to cloud. So that is the complexity, and this complexity that we've been talking right from the beginning of the panel is not ending anywhere, because there are so many flavors to 5G and everything that we talk about it.
Right, Nida. So maybe this edge computing will help in reducing the latency as well, because the processing will be near to it.
Yes. That's the main idea. Sorry, I'll just add
Yes,
that. That's the main idea of edge computing, is to reduce latency.
latency.
Like Swati mentioned initially, 1 millisecond is what 5G promises. And how do you get 1 millisecond? It's because of edge computing, because of the telco edge and the network edge. That is the promise of 5G. And it's coming because you're reducing backhaul and you're reducing it via the devices at the base station.
Yes. So promises are big, challenges are big, complexity is big. Yes, we are working. Yes. So Swati, I'll come to you. So as we move to 5G, are there any changes from security perspective which you are foreseeing? Because you worked in 2G, 3G, 4G, 5G. So what are your views on that?
Yeah, so as everyone earlier said, we had earlier, simple physical network functions everywhere. So it was very, very secure. Nobody was able to, penetrate into it. Even though we did have challenges of security in 3G, 4G, especially at the access layer, where the authentication of a user happens. So those technologies were already working. So here we are talking about all open. We are talking about all virtualization. We are talking about all IP transport layer. And then we are talking about millions and millions of devices manufactured by millions and millions of people. So all these things, as they are bringing the promises of 5G towards the network, every one of these is actually creating a potential threat to the security, because everywhere as you become as open up, obviously the security threat is there. And so the 5G as a technology has to have, I mean, it in its standard has to have a different thinking about the security, and they have thought about it. So there are security standards for the access domain, like for example the user getting authenticated to the network. There itself the access domain security features have been introduced, more stringent, right? Like a enhanced home control. So home network is able to control what if somebody is roaming around in the various devices, then there is a two-way authentication which happens. And the second is the network domain security itself. So once you've latched onto the network, between the network, and again we are talking about the cloud and also the network domain having the security requirements. The third is the user domain. So what the individual user plus the network element and the application layer security. So each application, how that is working. And last is the service domain security, because we touched upon it slightly. I will talk about it more in detail in terms of the network slicing. That is the biggest feature of 5G, wherein for every individual use case, you can have the resources divided logically for that use case to have the best optimized service to that use case. For example, if I'm using an enhanced broadband, I'm just browsing on the network, I don't need a latency of 1 millisecond or 10 millisecond. Whereas if there is a remote surgery which has to be which has to happen by the doctor, or it's a vehicle self-control vehicle, I mean the remote control vehicle which is going on, definitely that accuracy and that latency has to be there. So these different kinds of applications and their layers, they are all divided into the network slices. Now we don't want these network slices to have any security breaches amongst themselves. So each one of those layers have to be, so the visibility of the network for the management functions, or they are called all network slice managers. So they and the host platforms, both of them have to have such a secure environment that they cannot, that the security cannot be breached. So for that, 5G envisages something called end-to-end security. It's not a hop-by-hop security. For example, earlier in the technologies, we had the user domain security. Okay, it's only talking about the user and the network. And then it was application layers. Okay, it was only talking about the two application layer. Here, you're talking about an end-to-end security. That security is built into the systems by double authentication methods, by a subscriber identifier key which travels across for all the authentication, and the layers which we are talking about, and each of the layers having those separate secure standards. So in short, if you want to just talk about the security, it is mainly the secure environment which is to be created by 5G in every layer, plus an end-to-end security to be able to take care of the future. And as I mentioned, the IoT devices, or the number of millions of devices, there is a lack of right now standardization of IoT devices. So the devices, and thirdly, we are not only then talking about the standardized network function. For example, 3GPP standard everyone is following. We do have non-3GPP networks like a Wi-Fi. So the unified authentication system between a 3GPP and a non-3GPP. 3GPP is a global standard which is used for the mobile technology. So that also is another challenge, and that is envisaged in 5G to make it as secure and more secure as possible for customers or the users to have it usage. And it's all going into the industry, and industry cannot rely on a non-secure environment. And we are already seeing the challenges of security threats across, and the vulnerabilities which are created because of the openness of what we are talking about.
Right. Yeah, very rightly said. So because of openness, the security requirements increases, and also because everything is getting digitalized. So the security is more important now. Yeah, thanks, Swati, for that. So I'll come to you, Sridhar. So if you want to add something on role of 5G in IoT devices, we have already spoken a bit. So if you want to add something there.
Yeah, sure. Yeah, I think IoT is going to be massively changed with the rollout of 5G. There are various reasons for that. One is the 5G ORAN standards themselves do allow for the RIC to be customized based on AI techniques. Okay. So the AI models can be built on the fly and be deployed, and these could influence right from the radio characteristics all the way up to the connectivity and all those things. So and even the policy and the QoS policy, all these could be changed. So the kind of I would also take this opportunity to touch upon the ORAN standardization as well. So there is the ORAN standards body is divided into multiple working groups, and working group 1, while it is defining the architecture, there is also a branch of it called the use case group, and there is a lot of work happening on defining the use cases, and the already released standard does talk in great detail about many of the use cases there. So I just want to touch upon one of the use cases. It says that there is a drone which is flying into like for example a defense area, like a border of a country, and then the spectrum can be so tuned just for the duration of the drone flying into that area. The radio parameters can be optimized, and once the drone completes its tour, and not only just it can be optimized for getting video surveillance data out of that, and once it completes its tour and comes back, the network is back to its traditional, I would say, commercial kind of a policy. So you can deploy based on immediate need. You can change the radio characteristics of that is one aspect of it. The second is because of the AI/ML models, the network can learn that there is a particular surge happening or a trend happening, and it can intelligently figure out how it needs to optimize the parameters. So all of these are, I would say, good ingredients to build a good IoT system. The one other aspect I want to bring about is the evolution of this NB-IoT, narrowband IoT, which again is massively influenced because of these 5G rollouts. And narrowband IoT is just leveraging existing deployments, adding, and if you add 5G capabilities into that, it allows for what I was earlier referring to as private networks, NPN networks. So you can have industrial IoT is one of the niche areas for IoT, and industrial use cases for IoT coupled with 5G is going to be a game changer. So you could talk in terms of, for example, drones doing deliveries using 5G and IoT use cases. Those could be use cases as well. So I would say the sky is the limit. And again, I would also add, I know Nida is already smiling there. The startups and have a very big role to define new use case and become unicorns, I would say. So this is, I would say, a perfect melting pot for new ideas, new ecosystems, and IoT to create, I would say, satisfaction for customers.
Yeah, Nida, so a lot of onus on you.
So yeah, just to add to Sridhar, Gartner at one point of time said 109 use cases that 5G provides along with IoT and things of so sort. Of late, I've been doing a lot of research. Actually, they're not 109. There are probably about 4,000 use cases in the market, and it spans from agriculture to healthcare, like what Swati spoke about, robotic surgeries, to drone navigation, to fleet management, to learning and management of manufacturing units, minings, AR, VR. Oh my God, it does not stop. So the question that we often get asked is the chicken and egg problem, right? Will the use cases be defined first, or will the 5G rollout happen first? So that is where the question lies right now. So even though there are startups working on it, everything is dependent on 5G rollout.
Right, right. And for use cases, sky is the limit, as Sridhar said. Right.
Yeah.
Yes. So I'll take two more questions quickly. We are running out of time. So Nida or Sridhar, means anyone you can cover. So it's 5G, if you see, it's very hyped. Right. So if someone wants to contribute towards the 5G, or they want to learn 5G, so what resources or open source project they can join? So Sridhar or Nida, means anyone.
I will start, Sridhar, and then you can add to it, because I'll probably have a little bit startup view on this. So one of the projects, I mean, not as a fresher or a thing, but as a company itself, I think Etsy has a lot of Etsy has a lot of information on 5G itself. There's ORAN Alliance, which is also very important from a ORAN perspective, and does a little bit of open. Both Etsy as well as ORAN Alliance have a little bit of open source work. OpenStack has Starling X project, which is very focused on telco as well as the 5G deployment. In fact, a lot of cloud native work that they talk about. Carnegie Mellon has a Living Edge lab. Living Edge Lab also has test beds. Of course, it's not open to all the students in the world, but this is something where you can learn about edge native applications. And even if you do get associated, we are a part of Open Edge Lab today. There's Facebook connectivity, AT&T, T-Mobile, and so on and so forth. There's TIP Telecom Infra Project. Again, there are contributions, there are SIGs, and then you can be a part of it. Then a bunch of test beds. Even in India, test beds are opening up actually from IIT Bombay, IIT Madras, and IIT Delhi. So these are opening up, but the commercial aspect has not been defined as yet. So once those things open up, that'll be a good starting point. And those are all the mentions that I have. LF Edge is the last project that I'll talk about. LF Edge has a lot of open source aspects to it, and also 5G aspect to it. And then if I start talking about LF Edge, then there's Open Grid Alliance and a bunch of other alliances in the ecosystem. But Sridhar, I'll let you cover the latter part of it.
Yeah. So I more than the resources, I would like to focus upon how to get into a 5G. So suppose a person is not on 5G, how they can chart their journey into 5G. So it is pretty daunting. And I can tell you from my personal career, I was never in 5G. A good portion of my time was spent on networking and telecommunication on the IP and optics and all of that. And you start reading a 3GPP document or an ORAN document, you are like, gone. Oh my God, what is that? So, but the good part about this whole thing is nobody really knows the whole of 5G. Everybody is looking at 5G from their own perspective. The more and more I see the 5G ecosystem, the biggest learning I have is don't assume all the other people out there are experts and you know nothing. Don't ever start there. Everybody knows. How do I put the right negatives in there? Nobody knows everything. I think that is the reality of it. So there are people who approach 5G from the radio side of it, and for a person who does not have a radio background, that is extremely challenging. But 5G is not just radio. 5G is an ecosystem. 5G has platform aspect to it. 5G has a cloud aspect to it. And you can approach 5G from any of these particular, 5G has a chip technology into it. So you can approach 5G from any one perspective and then gradually learn the other aspects of it. And there is a good amount of hype on 5G as well. So especially while you read articles, be aware that there is an element of marketing into those articles. And you need to, as you spend more time on 5G, you will figure out where is the marketing part and where is the reality actually. And there are a few good sites as well who try to bring all this information from varied sources into one common place. And one particular site I have been relying upon is Devopedia. They have some fantastic articles about 5G, and all of those are cross-referenced to the original sources. I would say a good starting point for anybody who wants to enter into 5G, go read some articles out there, and that would help you to figure out. And then I think the ultimate is read the standards. There is no alternative to that. You have to reach there, and the intermediate path is a little it's a maze. We'll have to figure our way out in that path. Yeah.
Hey, I just wanted to add something. Most of my 5G related information comes from Ericsson website. I'm just putting it out there because there's so much information on Ericsson.
Thank you so much.
Yeah, thanks for that. So last question for Swati now, the burning question, so which is in everyone's mind. So when will we see 5G coming live?
Okay. So as I mentioned earlier, 5G is live in the rest of the world. It is already live. It's going. It's also live in India in terms of testing and the trials. So we saw a launch of 5G in Hyderabad by Airtel. We have seen now testing happening from Vodafone Idea in Gandhinagar and I think Lucknow. And then we are also seeing Geo, testing it across in terms of different phases. We are waiting for the spectrum to really get auctioned on the separate band for 5G, which will happen somewhere, I think, in the beginning of next year, where a 275 megahertz of spectrum of 3.3 gigahertz to 3.6 gigahertz will be really up for sales. And then definitely we'll see a big boost. But the operators are getting ready in India, all of them. Their core as well as the radio and and whatever they need to do in the backhaul. So that's and as everyone we discussed about, the infrastructure is a huge amount of work which is required to be done. So it's getting ready, and I'm sure that next year will be quite exciting as far as 5G is concerned. And meanwhile, like Nida, people like Nida and others are actually creating the environment, the rest of the environment. I think we will see a good. Just want to also talk about the devices as you know, I think right now, I just today in the morning conclave, I heard that 12% of the devices are already 5G coming in India right now. So obviously, as you grow nearer to the launches or the larger launches, I think we'll see most devices coming into the India. We already have IoT platforms working, so they getting converted. I think that will be here. So I think we are seeing this interesting move into the journey, and I'm sure that we all will be seeing a big jump into the 5G era across the world as well as in India in the coming years. Thank
Yeah,
you.
sure, Swati. Yeah, waiting for that 5G to become live. So with that, I'll close this session because we're already top of that time. So thanks to all the panelists for the very insightful, very informative session. So there's a loads and loads of information, so which will take some time to digest also. And I'm sure everyone must have learned a lot of things and must have been geared up to learn more and contribute towards 5G. And like Nida, many entrepreneurs will come up, yeah, with the startups again. So I can surely say that I have learned a lot and I'm fully motivated and excited for the 5G. So thanks to all the audience also. And now over to you, Sandhya.
Thank you so much.
Yeah,
Thank you so much to all the panelists for being there and patiently answering the questions. And this is like a tons of information and a good kickstart to know what 5G is and what is the future of 5G. So I am as excited as the audience are right now to see how 5G changes our lives. So I'm glad that I'm part of this panel, and there are a lot of takeaways for me. So thank you everyone for sticking till the end, and hope you enjoyed this session. So thank you to the speakers and our moderator. Thank you so much for putting this so amazingly. Stay home, stay safe, and there are other sessions panel up. So audience, please join the other sessions as well. And thank you speakers for accepting our invite. Hope you have a nice day. See you.
Yeah,
Thank
thank
you
you,
so
Sandeep.
much,
Yeah. Thanks, everyone.
Women Who Code panel. Thank you so much.
Thank you all.
Thanks, Adi.
Bye.
Bye bye.
Bye.
Thank you.
Bye bye.